4 years ago, on July 12, 2022, a space telescope that had spent nearly a decade delayed over budget and doubted by critics who weren't sure it would ever actually work, released its very first set of images to the public. They showed nebulas, galaxy clusters, and a distant exoplanet's atmosphere in a level of detail nobody had ever seen before. It was, by nearly every measure, a triumphant beginning. What almost nobody expected 4 years later is that the telescope would still be getting better. Not slower, not fading. Better, with sharper techniques, deeper exposures, and a growing catalog of discoveries that its own science team is now describing, in official statements, as revealing a richer, far more complex universe than even Webb itself showed us just a few years ago. This is a tour through some of the most recent, most genuinely significant images the James Webb Space Telescope has released, spanning the last year of its operation, from a glowing nebula that looks almost like it's staring back at you, to a hidden planet found tucked inside one of the most famous star systems in the night sky, to a newly identified class of ancient survivor objects sitting at the heart of our own galaxy. None of what follows needs exaggeration to be worth your attention. It's already remarkable, exactly as NASA and the European Space Agency have described it in their own words, through their own official releases. Let's start with where this all began, briefly, because understanding what Webb actually is helps explain why these newer images matter so much more than they might first appear. The James Webb Space Telescope launched on Christmas Day 2021 from French Guiana, the result of a collaboration between NASA, the European Space Agency, and the Canadian Space Agency that had been in development for more than 2 decades. It carries a primary mirror measuring 21 feet across, built from 18 individual gold-coated hexagonal segments that had to unfold with extraordinary precision after launch, since the entire telescope was too large to fit inside its rocket in its final operational shape. Unlike its predecessor, the Hubble Space Telescope, which primarily observes visible light, Webb is built to see primarily in infrared, a wavelength range invisible to human eyes, but extraordinarily useful for astronomy, since infrared light can pass through clouds of cosmic dust that block visible light entirely. And because light from the most distant galaxies in the universe gets stretched into infrared wavelengths by the ongoing expansion of space itself. Webb doesn't orbit Earth the way Hubble does. It sits roughly 1 million miles away at a gravitationally stable point called the second Lagrange point, where it can keep its heat-sensitive instruments shielded from the Sun, Earth, and Moon simultaneously, cold enough to detect the extraordinarily faint infrared glow of the earliest galaxies in the universe. With that context in place, here's where the story becomes genuinely current, because Webb's most recent releases show a telescope that isn't just still working. It's producing some of its most scientifically layered results yet, 4 years into a mission originally designed to last 5 to 10. In January of 2026, Webb released a striking new image of the Helix Nebula, sometimes nicknamed the Eye of God, a nickname earned by the nebula's genuinely eerie resemblance to a vast, glowing eye staring out from the depths of space. The Helix Nebula is what astronomers call a planetary nebula, a term that's a bit misleading since it has nothing to do with planets. It refers to the expanding shell of gas and dust that a dying sun-like star sheds during the final stages of its life, as its outer layers are blown outward while its core collapses into a small, dense white dwarf. Webb's new, zoomed-in view of the Helix Nebula revealed the intricate, delicate structure of that expanding material in a level of detail that had never been captured before, showing thousands of individual, gaseous knots and filaments, each one shaped by the complex interaction between the outward-rushing stellar material and the intense radiation still pouring out from the white dwarf at the nebula's center. It's a preview, in a very real sense, of a fate our own sun will eventually share. Roughly 5 billion years from now, when it too exhausts its nuclear fuel and sheds its outer layers into space, leaving behind a small, dense stellar remnant surrounded by an expanding, glowing shell, not unlike the one Webb just photographed in extraordinary new detail. The following month, in February of 2026, Webb turned its attention much closer to home, releasing a new image of Uranus that accompanied a scientific study mapping the vertical structure of the planet's upper atmosphere for the first time in history. Published in the journal Geophysical Research Letters, the research, led by scientists including Henrik Mellon and Lee Fletcher's collaborators, used Webb's infrared instruments to study Uranus's ionosphere, the electrically charged upper layer of its atmosphere, revealing detailed structural information about how that layer behaves that simply hadn't been accessible before. This built directly on earlier Webb observations of Uranus's magnetic environment, which had already revealed strange, warping magnetic forces around the planet, unlike anything documented at any other world in our solar system. Uranus is a genuinely strange planet by any measure, tilted almost completely onto its side, likely the result of an ancient, massive collision early in the solar system's history, and Webb's continued study of its atmosphere and magnetic field is steadily building the most detailed picture of that tilted ice giant world that has ever existed. In April of 2026, marking the telescope's 4th science anniversary, Webb's team released a new set of images of Messier 82, also known as M82, an edge-on spiral galaxy located about 12 million light-years from Earth, undergoing unusually rapid star formation. According to the European Space Agency's own description of the release, Webb's combined near-infrared and mid-infrared sensitivity revealed previously unseen detail within this well-studied galaxy, cutting through the thick dust that had obscured parts of its structure in earlier observations from other telescopes, including Hubble. M82 has been photographed by astronomers for decades, making it a genuinely useful test case for demonstrating just how much additional detail Webb's specific combination of infrared sensitivity can reveal in a galaxy. Scientists already thought they understood reasonably well. The anniversary release wasn't just a celebration of the mission reaching its 4th year of science operations. It was framed by ESA specifically as a demonstration that even familiar, well-photographed objects in the universe can transform into something far richer and more complex, once seen through Webb's particular set of eyes. Perhaps the most conceptually fascinating release from this period involved a discovery announced through Webb's ongoing observations of a stellar cluster called Terzan 5, sitting within the crowded, dust-obscured central bulge of our own Milky Way galaxy. Combining recent Webb observations with 12 years of accumulated data from the Hubble Space Telescope, researchers confirmed the existence of an entirely new class of astronomical object, which they've named bulge fossil fragments, with Terzan 5 serving as the prototype example. According to the European Space Agency's description of the findings, these objects represent surviving remnants of the primordial clumps of material that merged together billions of years ago to form the dense central bulge at the heart of the Milky Way. Nearly all of those similar primordial clumps merged and dispersed long ago, blending indistinguishably into the galaxy's broader structure. Terzan 5 remarkably remained intact, surviving essentially unchanged from that extraordinarily early period of our galaxy's formation all the way through to the present day. Studying an object like Terzan 5 gives astronomers something extraordinarily rare, a genuine physical fossil record of what the earliest stages of our own galaxy's formation actually looked like, sitting quietly within our own galactic backyard. Essentially preserved rather than fully absorbed into the churn of galactic evolution, the way nearly everything else from that era eventually was. Webb has also continued making progress on one of the more genuinely puzzling mysteries to emerge from its own earlier observations, a class of objects nicknamed little red dots, first identified in Webb's imagery back in 2022. These compact, unusually red objects, found scattered throughout the distant early universe, initially left astronomers uncertain about what they actually were, with early theories ranging from unusually dusty young galaxies to a previously unknown type of rapidly growing black hole. According to the European Space Agency's more recent reporting, new spectroscopic data gathered from one particular little red dot has helped connect many of the previously disconnected pieces of that puzzle, offering researchers a considerably clearer picture of what these strange, distant objects actually represent, and how they fit into the broader story of how galaxies and the supermassive black holes at their centers formed and grew during the universe's earliest chapters. It's a good example of how Webb's ongoing work often functions less like a single dramatic discovery and more like a patient, methodical unraveling of a mystery the telescope itself first uncovered years earlier. In a related vein, Webb's instruments have also been used to map the motion and chemical composition of the gas swirling around a supermassive black hole sitting at the center of a tiny, extraordinarily distant galaxy called Able 2744 QS01, located more than 13 billion light-years away, meaning astronomers are observing light that left that galaxy when the universe itself was still in its infancy, a small fraction of its current age. That kind of observation, resolving detailed motion and chemistry around a black hole sitting at nearly the edge of the observable universe, would have been essentially unthinkable before Webb's launch, and represents exactly the kind of extreme, boundary-pushing science the telescope was specifically designed to make possible. Closer to home in terms of the kind of subject matter rather than actual distance, Webb has continued to make significant progress studying planets orbiting other stars. One recent release, highlighted among Webb's official 2026 image catalog, involved the Beta Pictoris system, a young, well-studied star already known to host at least one confirmed giant planet. New observations revealed a previously hidden second planet within that same famous system, discovered using Webb's near-infrared spectrograph in its integral field unit mode, a technique that allows astronomers to gather detailed spectral information across an entire two-dimensional field of view simultaneously, rather than from just a single point. Finding an additional planet within a system astronomers thought they already understood reasonably well is a meaningful reminder of just how much detail remains to be uncovered even in some of the most heavily studied planetary systems beyond our own. Webb also released findings on a planet with a genuinely dramatic backstory. a world that appears to have survived the death of its own host star. According to NASA's description of the research, Webb's instruments studied both direct imaging and a transmission spectrum of this surviving planet, offering scientists a rare, direct look at what happens to a planet when its star reaches the end of its life and undergoes the same kind of dramatic transformation into a white dwarf that produced the Helix Nebula's glowing shell described earlier in this same set of recent Webb findings. Studying a planet that actually made it through that violent, destructive process intact offers real insight into the long-term fate that may eventually await any planets that survive around stars similar to our own Sun, once it too reaches the end of its roughly 10 billion year lifespan. Webb has continued its ongoing monthly tradition of releasing what the European Space Agency calls its Picture of the Month, a recurring showcase of some of the telescope's most visually striking and scientifically meaningful captures. In May of 2026, that monthly feature highlighted Messier 77, a barred spiral galaxy located roughly 45 million light-years away in the constellation Cetus, chosen specifically, according to ESA's description, for its relative proximity combined with the kind of spectacular structural features that make it a genuinely popular target among professional astronomers. Webb's mid-infrared instrument captured the galaxy's swirling spiral arms, the intricate dust lanes threading through its disk, and its remarkably bright central core in a level of clarity that highlighted features simply invisible in earlier observations from other telescopes. The following month, June of 2026, Webb's Picture of the Month turned toward a familiar region of the sky that the telescope has now photographed multiple times from different angles, the giant molecular cloud known as Orion A, home to the far more famous Orion Nebula, itself just one small piece of a much larger, hundreds of light-years wide complex of star-forming material. This particular observation looked specifically behind the well-known Orion Nebula, into a long, massive filament of cold gas and dust called the Orion molecular clouds, divided by astronomers into 4 distinct regions, according to Space. Com's coverage of the release, the resulting image revealed hidden, previously obscured stars actively being born within that dense filament, captured in what reporters described as some of the most colorful and vibrant detail the region has ever been shown in. It's a genuinely fitting kind of image for a telescope specifically engineered to peer through exactly the kind of thick cosmic dust that has historically hidden stellar nurseries like this one from clearer view. Taken together, this steady stream of releases, spanning nebulas, planets, distant galaxies, and newly identified classes of astronomical objects, tells a story that's easy to lose sight of amid any single spectacular image on its own. Webb isn't simply continuing to operate 4 years after launch. It's continuing to improve the depth, precision, and scientific reach of what it's capable of revealing, as its team refines observing techniques, develops new data processing methods, and identifies increasingly ambitious targets worth pointing the telescope toward. A mission that could easily have been remembered simply for its extraordinary first images back in 2022 has instead kept producing genuinely new science. Year after year, discovery after discovery, each one grounded in careful, peer-reviewed research rather than any single moment of viral attention. There's something worth appreciating in that pattern specifically, beyond the individual scientific findings themselves. Space telescopes, almost by definition, don't get maintained the way ground-based observatories do. Once launched, an instrument like Webb has to function essentially without hands-on repair for the entirety of its operational life, relying on the precision of its original engineering and the careful, ongoing calibration work performed remotely by teams back on Earth. That Webb has not only continued functioning 4 years into its mission, but has continued producing increasingly sophisticated, increasingly detailed science during that entire stretch, speaks to just how carefully that original engineering was executed, and how much careful, sustained effort the mission's scientific teams have continued investing in getting the most possible value out of every single observation. Webb was designed with a target operational lifespan of somewhere between 5 and 10 years, primarily limited by the amount of propellant it carries for the small thruster adjustments needed to maintain its precise orbital position 1 million miles from Earth. Early in the mission, more efficient than expected use of fuel during its initial launch and deployment phase led NASA to revise its own estimates upward, suggesting the telescope may ultimately operate considerably longer than its original minimum lifespan, potentially for 2 decades or more, barring any unexpected technical failure along the way. If that holds true, everything described here, the Helix Nebula's glowing eye, Uranus's newly mapped ionosphere, the hidden second planet at Beta Pictoris, the ancient survivor fragment at the heart of our own galaxy, represents not some late-career highlight reel for an aging instrument, but simply another chapter in what may end up being a genuinely long, sustained scientific career, one that's arguably still closer to its beginning than its end. 4 years ago, a telescope that had spent decades in development finally opened its eyes for the first time, and the images it sent back reshaped how millions of people thought about the universe, even briefly. What's happened since quietly, steadily, through a continuous stream of official releases most people never see unless they go looking for them, is arguably more remarkable still. A scientific instrument that hasn't just lived up to its original promise, but has kept exceeding it, one careful, peer-reviewed discovery at a time, from a distant nebula shaped like a watching eye to a hidden planet found tucked inside a star system astronomers thought they already understood. If you want to see what Webb points toward next, that story updates constantly, sometimes as often as once a month. Subscribe if you'd like to keep following it.